Hello, hello. This is Postgres FM episode number 64. This is Nikolay and Michael. Hi, Michael.
Hello, Nikolay.
And we are going to talk about Postgres 16 yet another time. Release happened last Thursday, which is good, a week ago. And what do you think in general?
Oh, I'm really happy, and I think it's great. Always great to see another major version. The team's really impressive, actually, shipping every year consistently, pretty much exactly every 12 months. Even it's very impressive, and lots of good things. Again, a couple of hundred features. We definitely can't list them all. I have seen and heard people's opinions that there aren't necessarily any huge features necessarily in this one. But I personally really like that they are continuing to improve some of the things that Postgres is best at. Continuing to improve on the reliability, a few little features that help with that, continuing to improve on SQL standard compliance, and on performance, obviously my favorite topic, but it's often a big reason for choosing Postgres. So I think I don't want to discount that these are important changes, even if they aren't necessarily shiny, brand spanking new shiny features.
Yeah, right. I'm in the camp who say no breakthrough features in this release. Obviously, there are several very good ones. I wish I had already all of them on my production systems, but in general. Yes, it's like a convenience release. A lot of hard work, of course. You mentioned like 200 changes, and it's, by the way, it's normal number for last years. Every major release, it's roughly 200 something changes. But I would like to say that without breakthrough features, it's also good because it means it's less. It's more reliable. DBS should love it because you have a lot of improvements. And imagine if, for example, threads idea already was implemented in this release. I would wait probably until 16.10 or 20 before trying it on production. But with this, the system is becoming mature in terms of features it's already providing. They are improving like logical replication. It was added many years ago, 6, right? Or how many years ago? In Postgres 10, right? I think so.
Yes, wow, 6 years ago now.
You're right, and it was not super complete in the beginning, of course, and then logical decoding originally, right? Right, and now last few years a lot of very good improvements. Again, still several things in to do, and I hope 17 will have more things like the deprecation of DDL. But this release adds 2 important improvements for logical replication and decoding, and it becomes maybe more than 2, right? And it becomes, definitely more than 2. And it becomes more like mature. It means that upgrading should be less risky. And we just benefit in terms of performance and features and capabilities. So like replication from physical standbys. Super good, I think. So my point is this is not breakthrough release, but it should be adapted with less effort and sooner, I think. I wish the upgrade process was simple. We discussed it many times. Of course, upgrade is always a task. But if you already use, for example, Postgres 14 and you go to 16 or 15 to 16, it's just a lot of good things to have, and risks are not super. Risks are not super high as it would bring threats or something like changing source code 50% of source code or something. So
yeah, I love seeing it that way. I hadn't considered it through that lens. But yeah, great point.
DBAs
I have
are
spoken to some
conservative.
people.
Yeah, DBAs are conservative guys. Usually, they prefer some reliable software to run. So I expect 16 should be very reliable because it's polishing things and improving many small pieces.
Yeah. Well, even developers are quite keen on their database just working in inverted commas. So I think it's a big selling point of Postgres is that it's been around for so long. It has been, it's run by sensible people, smart, sensible people who are also risk averse. So yeah, that's cool. And as you say, logical replication is continuing to improve, and two headline features, or 2 out of the 7 or 8 features that get called out at the top of the release notes are logical replication related. Would you like to start with those?
Yeah, let's discuss it. First of all, performance improvements for long transactions, right? So it can be processed in parallel mode on subscriber, which is like improvement, which is transparent for you. If you use logical replication and you have longer transactions, you just benefit from it. That's it. And this is good because usually if we have a bottleneck on the subscriber side, as we discussed in last episode, which was about logical replication. By the way, it's natural for us to start with logical because we're still in that context. So if you have bottlenecks on the subscriber side, usual trick is to use multiple slots and multiple subscriptions, publication subscriptions. But it has downsides, as we discussed. Foreign keys violation is normal for this case, or you need to say I want foreign keys to be maintained all the time, but then you will have lags. So it's quite tricky. And if you use a single slot, single subscription, obviously you don't have a lot of choice how to speed it up. But now for long transactions, it's already improved automatically, transparently for you. It's a good thing. Another thing is that you can logically replicate from physical standbys, which is very, very good thing to have because we usually say, it's a risk to have higher load on the primary. Of course, if it's just one wall sender and you have many CPUs, it won't saturate your CPU or disk or something. But if there is another risk to be out of disk space on the primary, and but it can be mitigated using relatively new setting. I don't remember the name, but you can say I don't want to exceed some specific threshold for my slots.
Yeah.
So but still I just don't want to mess up with primary in any way, and I can now move to secondaries. It's very good for logically replicate or to other systems such as Snowflake or a ClickHouse or something. For analytical needs.
Exactly, that's the use case I have heard for it from somebody. Somebody asked me if this was possible a couple of years ago, and I had to say, unfortunately not, because they wanted to replicate to, I think it was actually Redshift, just for analytical purposes, and they didn't want to put that extra load on their primary, but they had a replica doing nearly nothing, serving some read queries, but it was a little bit out, if it's asynchronous, I think they had it set up asynchronously. They didn't mind if their analytics were, however much their lag was out of date. It didn't matter that much. Right. So that feels like a really good use case for this.
It's also related to how logical replication survives switchover or failover, but it's not that. I saw this work is still in progress, and we discussed Patroni implements some workaround to survive failovers. But it's about primary. So if you have logical slots on primary, how not to lose them if failover happens? This is the question.
Yeah.
I think here we also have a question. If this secondary is down, we don't want to start from scratch, right? 2 more features about logical I now remember. One is related to the ability to filter by origin, right? It's like multi-master is native now. This is like
Yeah, so this
something small, but wow,
be careful.
huh?
Yeah, I think people I saw a very excited blog post about this saying whatever multi-primary is now possible and showing you how you can set up writes from two different nodes synchronizing to each other because logical replication, you can now filter any that came in, I'm forgetting the wording that they used for it, but any that came in on that
Origin?
node can get replicated. Yes, origin, perfect. But any that came in via replication, you don't send it out again. So if you were told it by a different node, but there's a ton of issues with that, aren't there? I saw a good blog post by.
Without this feature, you have infinite loop risk, right? So
Yeah.
like you replicated something, it was replayed, written to a wall, and it got replicated back, and you have infinite loop. And so this feature allows you to break this loop and replicate only your like local changes, not those which were already replayed by you from different origin, right? And do you think I was wrong, like saying it's not a big release? Because imagine this could be named as like multi-master support is here. Why not?
Well,
This feature
I
is
don't
already
like. I don't think
multi-master.
it's a good idea to. Well, I think we've talked more, and I know you're joking, or at least teasing me. But
I'm
I think it's
partially
dangerous
joking.
to call it that. Yeah, I
Why?
think it's dangerous because I think people would actually use it for that, and then they would end up in having loads of issues around data synchronization, or basically, I think there was a good blog post by Crunchy Data who just showed the most basic version of updating a row on one of them, leaving the transaction open in order to make it really easy to demonstrate, updating the same row but with a different update on the second primary, then letting them both go through, and you end up with, in fact, ironically, I guess, with each one getting the other one's change, but not their own. So it's, I think there's
But
problems
we
that people wouldn't anticipate.
can we say now that Postgres natively supports multi-master topologies?
With an asterisk?
I
That
don't
would be
know.
my argument.
All right. Okay. Well, I think multi-master is intentional split brain, right?
Okay, there you go.
And still we have a question how fast is to replay logically replicate. Like if, for example, some updated thousands of tuples, how cheaper it is in terms of I/O and operation CPU as well on the subscriber side compared to the publisher side. It's actually not trivial, but also not simple. Not trivial, but also not super difficult benchmark to do. I wish I checked it already. It's an interesting question. Because I remember BDR claimed that replaying is cheaper. We discussed it, yes. And if it's indeed in some cases cheaper, then in some cases it's good to have such topologies and multi-master approach. Bidirectional logical replication.
Mm-hmm.
Why?
And if a customer asked you if they should set up a multi-primary setup with Postgres 16 tomorrow, what would you say?
So right now I will stick with my regular answer. You don't want a multi-master, and then we dive into details and explain why. But still, like we can say already Postgres supports such topologies. Why not? Okay, let's change the topic.
Yeah.
Also logical. There is interesting feature. We also discussed it, but like related to what we discussed. I explained in last episode. I explained how to convert physical replica to logical replica.
Yeah.
And interesting that in Postgres 16 you can specify that you want to initialize in your logical replica. You want to initialize table using binary format. As I understand, I never tried it. But as I understand, it's a similar thing. I mean, bloat will be preserved, and it's faster. I mean, indexes just copy it as files. You don't need to wait your subscriber node to rebuild them, right? So this is what my understanding of this feature. Again, I haven't tried it. I tried different like recipe involving recovery target LSN, which we discussed last time. But it's interesting. Like I think I will use it in many cases because it's like now natively supported, and I can just provision my logical replica, preserving all the bloat, right? But I mean, downside you don't lose the bloat. It's like kind of not, you're losing this benefit. But good thing is that it's faster than dump restore approach, which is default.
And natively supported, right? Like it just feels less. There's less moving parts on your side. Less things.
Just SQL, just one SQL command, and you have it. It's good. So maybe enough logical today.
There's a good segue. Yeah, there's a good segue. You mentioned the parallelization, and it's not the only additional performance improvement around that. So that there was some planner improvements to allow parallelization of more join types, full joins and right outer joins, I think.
Right. I'm curious why right not.
So that's
left.
cool. Like it's nice. I don't see many right joins in the wild, but plenty of full joins. Do you see? Do you see more?
I write them sometimes. Well,
oh really?
Why not? It depends on your point of view, you know.
It's all relative, right?
Some languages have right to left writing also. So some people write with left hand, some people write with right hand. It depends. And sometimes you start, if you have like quite complex query, you might want to add one more table in the list of your source tables, and it might happen right join is more convenient for you. Of course, I agree. Left is more popular because of the way how we write queries. I write queries. Why not? I write all the types of queries. So why not? Yeah, let's maybe move away from parallelization. Let's talk about performance. What else about performance?
It's only slightly, or actually there's one more that mentions it in the headline features, although I think it's possibly more on the kind of reliability maintenance front, but improved performance of vacuum freezing. And actually vacuum...
It's from Peter Gagan about much less bytes written to wall, right? Like 5x improvement.
Yeah.
And it's a part of different work. It's part of reconsideration of how to perform freezing like more proactively, I think, as I remember.
Yeah, right? Exactly. And to avoid, so this is why I think it's more reliability related, because it's to avoid those heavy anti-wraparound vacuums that we've talked about several times, tripping you up on various things. So I think it's more around the kind of making vacuum more predictable and not as likely to, hit us when we least expect it. So I think that's really cool. It's a performance improvement in a way, but the benefits are further reaching, I think. And then the other big performance one I did want to call out was...
sorry, we don't have super boring structure here, right? So I smiled a little bit because I happened to read list the article this morning from AlloyDB, Google Cloud.
Oh yeah.
About how they implemented adaptive auto vacuum, which is interesting. Like also to read about this. I mean, AI performing vacuum. Many people dream about getting rid of vacuum completely, right? But let's AI solve this problem. Not getting. I don't know. Like I need to read about it.
I really like the approach Peter's taking, and presumably others as well. But I think he actually explained this quite well around the indexing changes he was making. But he seems to be doing the same around vacuum, which is trying to improve just how the efficiency of how it works and when it works. So sometimes doing a little bit more work up front to save lots of work in the future. That to me seems so smart, and so like makes so much sense for that to be in the database. Like, and it's not like artificial intelligence. It's just using deterministic approaches. You know, if you can do a little bit extra work now to save more expensive work in the future,
Right.
maybe that's worth the overhead.
Right. In Postgres 13 and 14, the optimization related to B3. And the word deduplication, as I understand, appears here again. This optimization for wall writes from freezing, it's also idea of deduplication. Am I right or not?
I've seen that word as well. I wish I understood it. I think we have to have a Peter on at some point to ask him the details. But I tried reading up on some of this stuff and it started hurting my head.
Yeah. Well, many very small, like local optimizations happened as well. I like the idea to improve set config performance. It's interesting. Like if you use a lot of changes of GUC, Postgres parameters, maybe you have your own Postgres parameters, including dot. You can say blah blah dot blah blah and assign some string to it. So this like became like much faster, maybe like 10x or more.
I saw your note about that.
Yeah. And also,
who doesn't think there are enough Postgres parameters already and creates their own extra ones? That's some brave people.
I do it all the time.
What do you create?
I mean, first of all, extensions do it. I don't get your joke, so I'm asking. Extensions do it. For
Extensions
example,
make sense.
auto-explain, you should know about it. Also, sometimes I put a lot of settings there. Sometimes I prefer putting settings for application settings in a table, but sometimes I put them as GUC gook. Just I say like up dot something equals something. For example, if you use PostgreSQL, it's natural for you like to put something to as gook parameter. It makes some sense, and it's good to have several choices, and you just choose what's more convenient and secure and efficient and so on. Another very small but interesting optimization, wall receiver is more smart in terms of waking up. If you have a server which is not doing anything, wall receiver won't be will be doing much less work, and also promote trigger file was removed to avoid some checks. So it looks like I've read one article, I don't remember in which, it looks like this idea to optimize these two parts looks like an attempt to save energy. If you're not using some Postgres server, it should do less movements, right? And not to it's eco-friendly changes. It's funny, but maybe it's so.
Maybe not do a checkpoint every. Maybe we shouldn't be doing checkpoints every 5 minutes. Yeah,
and also create wall. There is also timeout when new wall is created, filled with zeros, right? So maybe also. It's an interesting. I remember discussion about checkpoint timeout. Log checkpoint. It became default a couple of versions and years ago, right? And I remember discussion it's bad because it will produce records to log, and if nobody is using server, we are filling the log. Why? But it was made because benefits from having this log checkpoint on by default are much better because we need that information. Speaking of which, in 16, as I remember, now we can see in checkpoint log messages, we see LSN positions of checkpoint itself and redo starting point, which is sometimes good to troubleshoot. Yeah. So there is a lot of small convenience things. I think it's a convenience release. A reliable convenience release. This is what my impression, and which is not a bad thing at all. Right. What else we should discuss?
Yeah. Well, a brand new thing is the PGStat.io view that we've talked about before.
Yeah. The author is Melanie Plageman. Yes. And I
have no idea if you're pronouncing it right, but yes.
Right. I was at PGCon and was at her talk. Her talk, sorry. So it was good talk, and congratulations. This is very noticeable contribution, and people need it, right? So I personally am going to use it all the time, and I hope observability tools developers will integrate this to their dashboards and so on. For example, net data and so on. This is a good thing to have, and it provides I/O buffer, our favorite buffers, but globally for database, right? Which it doesn't provide.
And timings.
Timings and many details. It's good. You understand who is doing work. I/O work is the most expensive in databases, and in most cases, slow means a lot of work needs to be done, right? A lot of I/O work in databases, because a database is an application which is I/O intensive application, right? So I/O bound, we usually I/O bound, and the main thing to understand about this new system view is that it's at Postgres level for a buffer pool. It's not about disk. It's about buffer pool. So abstraction is high. It means that if you see a lot of I/O numbers, maybe they are. If it says reads, maybe it's reads from buffer pool, for buffer pool from page cache, and under buffer pool we have page cache. So maybe it's still all about memory. We don't know at this level. So reads is not disk reads. It's reads from the page cache to buffer pool.
Or it could be either, but we don't know, right?
Yeah, at this level we don't know, so we need to consult, for example, proc.io using our process IDs or some different tool. But it's already very good. For at this level, it's super important to have and useful. And also it doesn't track some I/O. It tracks I/O only related to the buffer pool. It doesn't track I/O, for example, wall writes or reads.
Exactly. But it does for auto vacuum. You mentioned you're going to use this all the time. What kind of thing do you imagine yourself using it for?
So if we have a problem in any analysis, we need to divide to segments. It's about budgeting. It's about performance optimization. Anything you need to perform some segmentation to understand where to dive in further. And this is perfect starting point. So I understand, database is slow, some developer says. They like to say this. Database is slow. We look at this, better to draw this in terms of a graph, colorful graph with segments. This I/O is from backends, this I/O is from checkpoint, or this I/O is from auto vacuum workers, and so on. And I quickly understand where the most work is done. Is it about backends or checkpoint or where? And then I can go to pgstat.io tables indexes or to pgstat statements. I can go down to pgstat kcache if I have it. This will be physical level for queries. Or I can analyze wait events also additionally. This is perfect starting point for performance troubleshooting.
Makes sense. And also, I guess, if you could rule out that it's an I/O problem. I know it probably will be, but if there's nothing lighting up here in your monitoring of this view, you can also rule out that it's either that it's I/O related or that it's maybe it's wall related. But we discussed monitoring and troubleshooting, and we have some kind of run book and also list of what monitoring should have. And troubleshooting run book number 1 means you have 30 seconds. You need to understand which directions to dig, and I'm almost sure we will include pgstat.io in versions for Postgres 16 and newer. So as a starting point for this quick and shallow analysis, as wide as you can and very shallow. This should be a part of methodology, I guess, for troubleshooting of performance. And in terms of tooling, it was the PG Analyze team Lucas and one of the developers were involved in reviews of this, so I'm pretty sure they'll be adding it to PG Analyze. I suspect it's already there.
Yeah, very likely. Okay.
Next thing I had, I think it's important, partly not because I've heard many people talking about it for 16, but because people talked about it so much being reverted from 15, was the SQL JSON stuff. So the SQL standard constructors and identity functions. These were reverted from 15 because they weren't quite up to standard, I believe, or they weren't quite ready. And it was a big deal. Lots of people were saying they were disappointed. And now that they've been added, or at least most of them, I was a bit surprised that they didn't make a lot of the various things I've seen on Postgres 16 already. So yeah, I think it's cool, and I think standard compliance is important. I hear about it quite often when people say why they're moving to Postgres or why they're picking Postgres in the first place. So I know this work can sometimes be thankless, so I just wanted to say I appreciate all that hard work.
Yeah, well, yeah, PostgreSQL for many cases is standard de facto already. I mean, it's syntax. So, and we know a couple of Postgres folks are members of SQL standard committee, which is good. And of course, supporting standard is always good. I wish, I work with JSON in SQL context all the time. I wish the syntax was less bloated, and there are ideas how to change it, but it would require change of grammar, heavy change of grammar. But still, I agree with you. Standard support is a good thing to have. On this note, syntax, I think breakthrough change is now we don't need to specify alias for subqueries in from. It hits everyone, like who writes SQL. At some point, you see this error for sure.
Very helpful error. It does tell you exactly what you're doing wrong, but doesn't.
Yeah, it says just add as alias.
Yeah.
And I think it's not standard, this change.
I suspect the standard requires you to need one, but I know other databases. I think this has come up quite a lot in migrations, from other databases that don't force you to do this, and it must be quite annoying. But also not. Yeah.
This is exactly my point. Here we probably deviate from standard, but for the sake of easier migrations, it's a good thing to have. But I personally am going to stop writing those aliases. Closing parentheses and space underscore was always already. I have a habit already writing this, but now I can drop this. Well, not now. In a couple of years, when production systems will be on 16, I'm going to drop this habit.
Yeah,
which is good, more convenient. Yeah, slightly back to performance. I'm one of guys who like to use some kind of newer. It's not new already, but newer SQL syntax. For example, you can order by inside aggregate function, which is interesting. Sometimes, for example, for DBA, you select from persistent activity, and you group somehow, for example, by state, right? Idle, active, idle transaction, and you want few examples of queries. You cut them using left function, for example, taking only 10 first characters, and then you aggregate using string AGG or array AGG, and then you think, oh, okay, I don't want arbitrary examples. I want the longest lasting queries, for example. And you say inside string AGG or array AGG, you write right inside there. You write order by query start or exact start, and it limit will be applied using array. Indexes different, but you order by inside aggregation, you can specify order. So now when I used it, I always understood that it's not going to benefit from any indexes. It will be in memory, so it's quite not scalable approach. I mean, not performance is not good. If I have billion rows, I probably won't do it. But for persistent activity, it's good. So now the planner can use indexes to support this order by inside aggregate functions, which is good, and also distinct inside. You can write distinct inside it also. So
very cool.
String AGG distinct. This support was always there, but it was not benefiting from indexes. Now it can benefit from indexes.
So, yeah, these planner improvements they get quite in detail. But if we didn't have these continually being added, if we didn't have these added over the past few years, all of these things add up, right? It's very cool that it can do that.
Yeah. What else? And 150 more changes, right?
Yeah, right. Yeah.
Which we don't have time to cover. Yeah.
I'm scanning the ones we pulled out to see if there's any we really have to cover. What about just generally? You mentioned like updating production in a couple of years. I see some people upgrading every year, or at least most years, but they don't seem to be in the majority. Every couple of years does seem to be really popular. I know there is overhead to doing major version upgrades. I think that's the reason. Is there anything else you wanted to add there?
About upgrades? That's a huge topic. We already discussed.
No. About like, should people upgrade? How often should they upgrade? Is it okay to still have like a Postgres 12 instance lying around and just keeping it up to date on the?
So usually you should upgrade minor upgrades the newest in most cases, but again, like enterprise approach should involve proper testing in lower environments. But for major versions, it depends on each case. But in general, old school recommendation is wait until, for example, 16.2, a couple of 3. It will be already third minor version, 0, 1, 2, right? And then upgrade if you have some kind of critical system. But here again, my point is that for 16 probably we have more stable release because not half of source code was rewritten. Mm-hmm. How to say, how Postgres is built was changed drastically, right? Moving to Mason, new system to build. Which is the same system for all operation, like the same approach now is used for Linux, FreeBSD, macOS, Windows. So it's a newer approach, and a lot of legacy was removed. But it's behind the curtain for users, right? You don't see this because you just take the binaries.
It's good for the Postgres developers and for people testing patches.
Yeah. So more unified and more modern approach to build Postgres, right? Mm-hmm. Okay.
Actually, one thing I really did want to say quickly, and I'm surprised we haven't had more requests for this, is that I think probably the biggest thing that's happened to Postgres in the past year is outside of Postgres itself, which is, I think, the PG Vector extension. I suspect we're going to do a whole episode on it at some point.
Yes, we should. We should.
But it's cool because of the extensibility that these massive changes can happen outside of the major version release cycle. So yeah.
I have different opinion here. So I think PG Vector should be part of Postgres as soon as possible, but obviously it would mean that releases would happen only once per year, which is currently for PG Vector is quite slow because the pace of development is super high right now. But if it's still like if it's third-party extension continues to be so, like it's also losing some attention. If you, for example, JSON was in core, right, right away.
Yeah,
and this was good.
It's kind of why I wanted to bring it up because it could easily have been something that was decided to be put into Postgres, but I imagine it would have taken an extra couple of years, and maybe it still will. Maybe that is what will happen. But it's really cool that it can be out there in the wild, getting quick releases that aren't tied to the Postgres major version like cycle, And if it is in all the major cloud providers already, it kind of is in Postgres, like it is in a way, because anybody that self-hosts can install it, and anybody on cloud
I
platforms
don't
can.
agree here because
Okay.
if you check, for example, versions are maybe very old. For example, they upgrade slowly and so on. Or
Good point.
also some providers still don't support it, and also if it goes to core, there are two paths. It can be as contrib module, like officially supported extension, which is already good, or it can go directly to core. And I imagine a lot of discussions when people think what to choose, Postgres or specific vector database to store vectors, or I don't know, Elastic or others. They all support vectors, either by third-party extensions as well, or in core. I think support in core can be argument for choices. This is like argument, it's very high-level argument, not very diving to details, but some people might think, oh, if it's in core, it's better supported, And you cannot say, like, you can try to convince, no. So every like RDS adds support. Cloud SQL adds support. By the way, it added, right? Cloud SQL. There was a question.
It did.
Recently.
It did, but I think not the latest version, not 0.5.0, which is an important release. So you make a good point on they might support it, but is it up to date?
Without HNSW indexes, right?
Yeah.
Which is everyone wants right now, almost everyone.
Yeah.
So, by the way, about PG Vector, someone did very, very good point in my Twitter when I was discussing it, saying that, with HNSW indexes, it breaks the rule, like indexes should not change what is returned by query. But these approximate neighbor search, they will produce different result. Like without index you have one result, with index you have different result. And this probably like the thing Postgres never had. I mean, never had in core. It can extensions
have
can
heard.
be heavy. Yeah. So it's
I have
interesting.
heard that is a reason for not including it. But
I think
we'll see, I guess.
I think it should be in core because it will like Postgres is good at JSON, it should be good at vectors, obviously. So but yeah, I understand some obstacles here.
Sorry for the detour, but I thought that was worth adding.
It's a good topic. I think for future it's very interesting and very attractive for many. Very attractive topic. Okay, thank you for interesting discussion as usual. And let's remind our listeners that we need feedback, either in terms of subscriptions, likes, or maybe comments and suggestions what to talk about. And we still continue working on subtitles. All new episodes have them. We are improving, so feel free to use them and just also give us feedback, please, on Twitter or on YouTube or anywhere else. Thank you.
Thank you. Bye.
Bye.